So what I'd like you to do is to answer the following question. Do you have, oh, now wait a second. This says polling closed. Let's see whether we can get polling to open. Do you, no, that didn't work. Oh, this is the most desperately horrible thing that I've ever had happen. Okay, current slide. I've had horrible things happen that are worse than this. I'm sorry. I don't want to belittle all the really horrible things that have ever happened to me. Okay, so let's try again. Clicker practicalities, blah. Okay, do you have a clicker yet? Polling is open. Okay, and there's 10 seconds left. You'll see this little timer, 9, 8, 7, 6, 5, 4, 92 of you. So many of you have clickers. Okay, let's see what we learn. It looks like 97% of you have clickers. Now, I actually began with this exercise to make a point about psychological research. We just made a classic and dangerous mistake, a mistake known as sampling bias. We used a measure which doesn't give us accurate information about what we wanted to find out. We wanted to find out what percentage of people in the room had clickers. And what we found out instead was what percentage of people in the room with clickers had clickers. I don't know who you guys are. This error is an incredibly dangerous one, and it could have persisted. Suppose I then ask you a question whether you're from the class of 2014, 13, 12, or 11, and discovered that 80% of you were freshmen and sophomores. There again, I would have inherited exactly the sampling bias error that we just observed. Freshmen and sophomores have handed in their schedules already. Consequently, they're certain about what classes they're taking. Consequently, they're more likely to have clickers already. So when we do psychological empirical research, we need to be extraordinarily careful that the means by which we are choosing subjects for experiments are, in fact, means that give us an accurate sample of what it is that we're interested in. An article appeared recently in the journal Behavioral and Brain Sciences with the title, "The Weirdest People in the World." And weird here stands for Western, educated, industrialized, rich, and democratic. That is, American college students, people with access to online internet polling, and what the article argued was that a great deal of psychological research that claims to make general assumptions, that claims to prove general assumptions about human nature is biased in exactly the way my poll concerning what percentage of you have clickers was biased. It looks at a small sample of the population, those who are readily available to research laboratories on university campuses, for example, the introductory psych pool, and it bases its conclusions about human nature on that sample. Throughout the semester, we need to be attentive when we read psychological studies which are making claims about human nature to the fact that it is possible that some of the things which we are told apply to human beings in general instead have at least been shown conclusively only to apply to weird folk, Western educated, industrialized, rich, and democratic. And in certain cases, the data would look very different if we looked at a different population. This is also the case in the classical texts we read. The process that Plato and Aristotle took on for themselves didn't look experimental in the way that experimental psychology looks experimental, but they looked at a sample of people around them, and on the basis of their experience, they drew conclusions about human nature. So, little reminder of something that I said in the first lecture that sometimes gets lost. In some ways, this is a class about philosophy and the science of human nature. And in other ways, this is a class about Western philosophy and the science of Western human nature. And we need to be attentive to that when it becomes relevant. So what I want to do in today's lecture is to return to the issue that we took up last class, which is the issue about the multi-part nature of the human soul. And you'll recall that in the last lecture, we were introduced to Plato's great analogy of rational spirit and appetite, as exemplified by a charioteer, a calm horse, and a wild horse, and also to a number of other distinctions. Left brain, right brain, which I managed to get wrong 4 times in a row, if I remember correctly. We were introduced to the difference between brainstem and upper brain. We were briefly introduced to Freud's idea of superego, ego, and id. But we didn't get to work in the dual processing tradition. And today's lecture will take up where last lecture left off with another way in which it is typical to distinguish parts of the soul. Let me say that there is very good reason to think that the research which I'm presenting today is not subject to the weird objection. That is, there have been powerful cross-cultural demonstrations of nearly all the results which I'll be talking about today. And there are also good evolutionary reasons to think that the two systems which dual systems theorists posit are, in fact, going to be part of any human being because of the evolutionary process which all of us underwent. So I want to start with a picture of Edward Thorndike, not because he's important, but just because he's so fabulous looking. This is from the New York Public Library archives. Edward Thorndike was a late 19th, early 20th century psychologist who did a lot of important associationist animal work. But he also did research, publishing an article in 1922, that in some ways can be seen as the founding work of the reasoning tradition that Jonathan Evans described in the article that we read for last class. So he describes in this 1922 article an experiment that he does, which is entitled The Effect of Changed Data Upon Reasoning. And what he's interested in there is the question of whether problems that are posed to people that are formally identical, but that differ in how that formal material is presented, are processed differently. So, for example, he asks people either, what is the square of x plus y? First, outer, inner, last, I think is how you would do it. And he asked people, what is the square of b1 plus b2? Whereas people found the first question easy, they found the second question much more difficult. Success rates on this were up around 90%. Success rates on this considerably lower. Or he asked them, what's the square of a squared x cubed? Versus what's the square of r subscript 1 to the 8th, r subscript 11 to the 2nd, and so on. Presenting people with problems that were formally identical, but which differed in terms of the complexity of the characters used to represent them, produced a massive decrement in performance. Fast forward to a period in the 1960s, 70s, and 80s in which people began to study syllogistic reasoning, and a number of special instances of this phenomenon emerged. So in the Jonathan Evans piece that you read for last class, you were presented with examples like this: a syllogism that was valid and believable, that is, whose formal properties guaranteed that if the premises were true, the conclusion was true, and as a matter of fact, the conclusion was true, and arguments that were valid but unbelievable. Arguments where the structure of the argument guaranteed that if the premises were true, the conclusion was true, but where the conclusion was false. So, for example, you might be told no Greek tragedies are comedies, some Greek comedies are plays, and asked whether it follows from that that some Greek plays are not Greek tragedies. No Greek tragedies are comedies, some Greek plays are comedies, therefore some Greek plays are not Greek tragedies, and 90% of people were able to see that that argument was valid. By contrast, you might be given an argument equally valid, but with an unbelievable conclusion, like no Russian novels are short, some novels by Dostoevsky are short, therefore some novels by Dostoevsky are not Russian novels. That's a valid argument. It's a valid argument with a false conclusion because one of the premises is false. But as a result of the conclusion being implausible, only 55% of people were able to recognize that the conclusion followed from the premises. Notice, however, that these two arguments are structurally identical. They both have the form no A's are B's, some C's are B's, therefore some C's are not A's. Formal properties alone don't determine our ability to judge validity. And in fact, it is also true that formal properties alone don't determine our ability to judge invalidity. So whereas valid arguments with plausible conclusions are judged to be valid roughly 90% of the time, we just heard that, valid arguments with implausible conclusions judged to be valid considerably less often, an opposite error arises in the case of invalid arguments. Invalid arguments with plausible conclusions are judged to be valid. It's judged to be the case that the form of the argument guarantees the truth of the conclusion. Whereas it turns out that what guarantees the truth of the conclusion in that case is nothing other than facts about the world, as opposed to facts about the structure of the argument. In light of this Thorndikean tradition, researcher after researcher came up with research paradigms that demonstrated what we've just been talking about. So famously, the Wason selection tasks ask people to determine which of 4 cards they need to turn over to verify the truth of a statement. So for example, I might give you the statement, if there's an A on the one side, there's a 3 on the other, and I might present you with 4 cards and ask you which ones you need to turn over. Obviously, you need to turn over the A, and everybody recognizes that. You need to check whether there's a 3 on the other side. Obviously, you don't need to turn over the D. You know that cards have a letter on one side and a number on the other, so there's no worry that there's an A on the other side here. But people have a tendency to think that you need to turn over the 3 and that you don't need to turn over the 7. But look out. Right on that other side of the 7 was an A, and the statement turns out to be false. The ones you need to check are the A and the 7. People find this task relatively difficult. But here's a structurally identical task that people find relatively easy. If a person is drinking beer, the person must be over 21. I show you 4 cards: the beer drinker, the soda drinker, the over 21-year-old, and the 17-year-old. And every single one of you could, I take it, get a job as a bouncer, walk in, discover that the 17-year-old is drinking a beer, and thereby learn exactly what was hard to see in the earlier case, that the cards you need to turn over are the first and the last, rather than the first and the third. Now, there have been all sorts of explanations hypothesized for why it is that we find the second of these tasks easier than the first. Perhaps the most famous of these is a hypothesis advanced by the evolutionary psychologists Leda Cosmides and John Tooby, who argue that we have within ourselves what they call a cheater detection module, and that we're enormously sensitive to cases that involve violations of normative rules. So you'll notice that the second one is different from the first in 2 ways. One is that it's socially embedded, whereas the first is purely abstract. And we'll discover as we continue our readings this semester that social embedding awakens reasoning processes that aren't present otherwise. In fact, we learned that last week with the eyes study, when we learned that people are more pro-social, more likely to engage in morally normative behavior when they're presented visually with eyes, in part because it awakens and activates a kind of social understanding which all of us has. So the first difference between the bottom and the top is that the bottom one invokes sociality, whereas the top one is purely abstract. And the second difference between the bottom and the top is, of course, that this is a normative rule. It's about how things ought to be, whereas this is a descriptive rule. It's about how things are. So the lesson that we can take away from the Wason selection task, and those of you who are interested in it, there have been thousands and thousands of variations done on it, which are extremely interesting in sorting out exactly where people are good and not so good at the task. The lesson that we can take away from it is the lesson that has been emphasized throughout this lecture and the previous one, that we have ways of processing information that don't merely track formal properties. And some of those ways of processing information involve bringing online, so to speak, what Plato would call parts of the soul which had not been previously attentive to the situation. Now, is there a question in the back?
Yeah, sorry, for the last one, what exactly were the subjects asked to do? I don't really understand the experimental design.
So the experimental design for both of these cases runs as follows. You're given a sentence that you need to verify the truth of. So you're asked, is it true that if there's an A on one side, there's a 3 on the other? Is it true that if a person is drinking beer, the person must be over 21? And you're told that you have 4 items in front of you, and you're asked, which ones do you need to turn over to verify the statement? So to verify the statement, if there's an A on one side, there's a 3 on the other side, you need to turn over the A and the 7, not the A and the 3. And that should become obvious to you if you look at this case, where to determine whether if a person is drinking beer, the person must be over 21, you need to turn over the card belonging to the beer drinker and the card belonging to the person who is in fact not over 21. Does that clarify? Excellent. Okay, so dual processing accounts attempt to provide a general explanation for what's going on in the cases I've just described and the cases I'm about to describe. They suggest that we have two relatively autonomous mechanisms for processing information. And they're called all sorts of things, but what's become the most normative way of describing them is to call them simply System 1 and System 2. So whereas System 1 is evolutionarily primitive, it makes use of parts of the brain that came into our evolutionary process relatively early in the game. System 2 is evolutionarily relatively recent. It involves higher cortical functions. System 1 is unconscious or preconscious, whereas System 2 is conscious. System 1 operates automatically, whereas System 2 is consciously controlled. System 1 is effortless. It happens without our trying. System 2 is effortful in the sense that it involves an expenditure of cognitive energy. You have to pay attention. System 1 is super fast. It processes information almost instantaneously. System 2 is, relatively speaking, slow. The information that we get through System 2 takes considerably longer, seconds rather than milliseconds. System 1 is associative. It recognizes patterns in the world. System 2 is rule-based. It can apply principles. System 1 is, people sometimes say, reflexive. It happens without reflection, which is what underlies System 2. So the distinction between System 1 and System 2 is the result of many decades of work by many people. Here's a chart from a different paper by Jonathan Evans, in which he enumerates, and this will be available to you on the V2 site, some of the many researchers whose work went into talking about System 1 and System 2. And I want to point out to you on one important thing here, which is that it's a bit misleading to speak of System 1 and System 2 as if they are individual things. System 1 is sometimes called the autonomous set of subsystems. The idea there is that there's visual processing and there's auditory processing and there's processing that gives us information about very specific things like faces or the average length of lines, or that enables us to recognize something as predator or prey. All of those systems have the characteristics which System 1 does. They're quick, they're unconscious, they're evolutionarily primitive, they come online without reflection, but they are not, each of them, they are not altogether a coherent system. So dual processing accounts are a way of trying to make sense of a set of phenomena, some of which have to do with the processing of reasoning, and some of which, as we learned in the absolutely lovely Nobel Prize speech of Daniel Kahneman, which I asked you to watch for today, some of which take place in a more general domain of reasoning. And I've reproduced for you here Kahneman's beautiful chart explaining his understanding of the relation between System 1 and System 2, where he talks about the similarities between perception and intuition on the one hand and reasoning on the other. And again, I'll leave this slide for you on the website. So what I want to do in the next part of the lecture is to move from the discussion of Evans, which in some ways was left over from last lecture, though connected to this one, and talk a little bit about the work of Daniel Kahneman and his collaborator, Amos Tversky. So you're now going to get your second chance to use your clickers. We're only doing one other try today, and if this one works, we'll have a whole slew next Tuesday. Okay, so this is the famous Asian disease problem from Kahneman and Tversky, and it runs as follows. A terrible disease has struck 600 people in your town. Without treatment, they're all doomed. You are the mayor, and there are 2 courses of treatment available. If your last name begins with the letters A through L, you're going to need to read the information that I'm going to put in the green box. So put your head pointing over to this side and only read what happens in the green box. If your last name begins with M through Z, you're going to read information in the blue box. And let me tell you, we will use these color conventions throughout if this ends up working, and that the A through L group is always going to have numbers 1 and 2 for yes and no, and the M through Z group is going to have numbers 3 and 4 for yes and no. So if you're an M through Zer, look at the blue and get your fingers ready on 3 and 4. And if you're an A through L'er, look at the green box and get your fingers ready on 1 and 2. I asked Marvin Chun how to do slides like this, and this was his suggestion. Okay, so ready? I'm going to tell you about Plan A and Plan B. So look at your side of the board and not the other. Okay, so read about Plan A. And now read about Plan B. Okay, get your clickers out. And if you are on the green team, use 1 to indicate that you choose Plan A, and 2 to indicate that you choose Plan B. And if you're on the blue team, use 1 to indicate that you choose Plan A, and 2 to indicate that you choose Plan B. Okay, I'm going to put on the timer. We have 64, 66 zillions and zillions and zillions of responses. And let's see how the numbers come out. Okay, here are our numbers. Okay, those of you on the green team, 40% of you chose Plan A. Those of you on the blue team, only 25% of you chose Plan A. Ah, you know what? This is actually not a good way. So the relative size of the bars is relevant, but this is divided into 100. I need to learn a little bit more about how to use clickers. So let me now regroup and make my point again. As you'll notice, on the green team, the relative preference for Plan A exceeded the relative preference for Plan B. Whereas in the very small second half of the class, which consists of, the problem is that 60% of you are in A through L, and only 40% of you are in M through Z. This is our problem. Okay, but in this group, if I could quickly do 26 times 0.4, we would be able to find out what absolute percentage it was. In this group, the relative preference is for Plan B rather than Plan A. Notice, however, that Plan A and Plan B are identical. There's 600 people. And under Plan A, 200 people will live, which means 400 people will die. And on this side, there's 600 people. If we go with Plan A, 400 people will die, which means it's certain that 200 people will live. However, the results which you all showed are, in fact, exactly the typical set of results. Typically, people presented with a problem that involves a choice between certainty and probability framed in terms of its positive outcomes will go with the certain rather than the risky plan. Whereas people told the same thing where they're given to focus on the certainty that 400 people will die tend to go with the probabilistic option. Notice again, Plan A and Plan B on the two sides are exactly the same. Just one is framed in terms of who will live, the other in terms of who will die. And the result is almost a complete inversion of people's preferences. And we get these sorts of framing effects over and over. So here's a study by Kahneman and Tversky's student, Eldar Shafir, from the early 1990s. You go to an ice cream store and you're hoping to get yourself 2 flavors of ice cream. One is a good flavor. The other is an excellent flavor, but it has high cholesterol. And you discover that you only have enough money to buy one of the ice creams. So if I ask you, which one do you choose? 28% of people choose the good flavor, and 72% of people choose the excellent flavor with high cholesterol. But if I ask you, which one do you give up? 55% of the people give up the one with good flavor, and 45% of the people give up the one with the excellent flavor, high cholesterol. So even though, in this case, 28%, even though these are exactly the same question, which do you choose? If you choose A, you give up B. If you choose B, you give up A. These numbers don't match up. When you're asked which one you choose, the excellence looms large. And so you go for it, neglecting the high cholesterol. When you're asked which one you give up, the high cholesterol looms larger. This phenomenon occurs over and over again. Suppose you're going to a movie, and when you get to the theater, you discover that you've lost something from your wallet. What you've lost from your wallet is either a $10 bill or a $10 movie ticket, which you had purchased last night for the movie. So you get to the theater, you open your wallet to go in, either in the first case to pull out the $10 bill to buy the ticket, or in the second case to pull out your admit one ticket to let yourself in. And you discover that you've lost the item that would have enabled you to get into the theater. However, you have another $10 bill in your pocket, and the question is, do you buy another movie ticket? For people who've lost a $10 bill on the way to the movie theater, 90% of them say, I lost a $10 bill, but so what? I'm going to buy a movie ticket. For people who've lost a $10 movie ticket, which is of exactly the same value as the $10 bill, only 42% say that they would spend the $10 to buy another ticket. So framing is one of the examples of a heuristic or bias, which Kahneman and Tversky focus on in their work. We will return to some other examples later in the semester when we read the work of Cass-Sunstein. What I want to point you to now is a particular example which is going to serve as our segue into the idea of alief, and that's the distinction between frequency and probability. So suppose you're trying to get a red ball, because getting a red ball will help you win a prize. And you have a choice about whether you want to draw from this box over here, which has 9 white balls and 1 red one, or this box over here, which has 8 red balls and 92 white ones. So here you have a 10% chance, here you have an 8% chance. And you're going to be drawing from the boxes blindfolded, an image for which I don't suggest doing a Google search. So I found blindfolded justice. That did a little better. All right. So you have your choice. Do you want to let this box be the one? You're trying to get a red ball. Do you want to let this box be the one? Or do you want to let this box be the one? Well, obviously, rationally, you've got a better chance over here. But people are, in fact, pulled in 2 directions. You have a 10% chance over here, but my goodness, there's 8 balls over here. 8, 8, 1, 8, 1, 8, more. What's going on here, I suggest, is that whereas you have a belief that here you have a 10% chance, you have what I call an alief, that here there are 8, whereas over there there is 1. So, alief is a notion that I've actually discussed on Blogging Heads TV with Paul Bloom. And though we were filmed in totally different places, here I am in the game room at my house with our geo puzzles. Here's Paul in his study. It appears that we were separated at birth because that's at the same time, and that's at the same time. All right. So suppose I take you to the Grand Canyon, and I bring you out on a glass walkway that extends 4,000 feet above the roaring river below. And you step out there with me, and you voluntarily remain there. I take it if you voluntarily remain on a glass surface 4,000 feet above a roaring river, you believe that the surface is safe. Nonetheless, I will wager that most of you would shudder and shiver and shake. And you do so because you have what I would call an alief that says to you, I am 4,000 feet in the air with nothing holding me here, and I'm going to tremble. Or suppose we're watching a Western movie. Anybody recognize that gentleman? Guys, he was president when you were born. When you watch a movie, a Western movie, and the bullets are flying off the stage, obviously you believe that you're safe. You don't think, oh, what a good thing it was that the bullets didn't come off the screen this time. Nonetheless, particularly in 3D, you will bend your head down. If a green slime is coming off the screen, you'll tremble in your seat. If Anna Karenina is about to die, you will cry, not because you believe that you're in danger, but because you have an alief. How many of you set your watch 5 minutes fast and then subtract back down? When you do it, you believe that it's 10, but you have an alief. You look down at it, 10:05. It enters your visual system. It gets processed really fast, and it says 10:05. Hurry. Or suppose you're watching a rerun of your favorite team on television, and you know that if one of the guys on the team tries to steal second, he's going to be thrown out. And so you yell at the television screen, don't run, don't run. Why? Because you believe that your voice is going to go through the television screen back in time to first base to reach the runner? No, you have a belief that it's a rerun, and your alief says don't run. Suppose you're on a diet, and you see this beautiful piece of chocolate cake, and you have the belief that it's undesirable. Your alief system, in the form of your Platonic horse, may nonetheless pull you towards it. Or suppose I present you with this delicious cake. Those are Tootsie Rolls. This is a perfectly clean, sterilized pan. That's coconut there. In fact, this one has the same ingredients as that one. Exactly. You believe me, right? I'm your professor. You're here listening to what I tell you. I tell you this is edible. Tootsie Rolls, coconut. Nonetheless, I take it that your alief system kicks into gear. Suppose I ask you to sign this contract. I hereby declare that my soul belongs only to you, O Satan. And I write at the bottom, this is not a legal contract. It's just a prop in a psychology experiment. You will nonetheless be reluctant to sign, not because you don't believe that this is a legal contract, right? Oh my goodness, I just signed my soul over to the devil. I can tell it's the devil, it's parchment. No, you believe that there's nothing to it, but nonetheless you hesitate. Suppose I take you to Monica Bonvicini's bathroom, which is, as you can see, completely opaque from the outside. You stand outside this public restroom, you peer into it, you see that there's no way to see inside. Your belief is that you are totally protected. Nonetheless, when you go in to use the facilities, it looks like that, and your alief makes it rather difficult to do what you had gone in with the intention of doing. Suppose we have a bag of sugar and 2 glasses of water, and you take a spoonful of the sugar and you put one in this glass and label it sugar, and one in this glass and label it poison. You took the sugar, you put it into the glasses, you put the labels on it. Nonetheless, people are reluctant to drink from this glass. Moreover, they're not just reluctant to drink from it when it says poison, they're reluctant to drink from it when they've written the words not poison on it. Why? Because the word poison is there running into your leaf system, and your thought is sugar, good sugar, drink sugar. Poison, not, oh, poison, poison, don't drink the poison. Okay, suppose that I have a kitchen and that I'm interested in making some kitty litter cake, so I have my cake pan stored over here. And the chef comes in and says to me, it would be much more efficient if the cake pan were over on the right. He's very pleased with what he's done, and when I ask him to get the cake pan, he says, I'm so happy that we've moved the muffin tin to the right-hand cabinet, and goes to get it, believing it to be on the right, exactly where it used to be. His belief is that it's on the right. His alief is a lagging habit. Any of you who's ever rearranged your room knows this feeling. Any of you who has ever put your cell phone in your hand and then looked for your cell phone? I've had terrors of having lost my children and then realized they were on my shoulder. So to have an alief is roughly to have a representationally mediated propensity to respond to an apparent stimulus in a particular way, right? So the apparent stimulus of the glass staircase, the apparent stimulus of the kitty litter cake, you have a propensity that's either innate, as in the case of the glass or the fudge-shaped like feces, or a habitual propensity, as when you've arranged the kitchen. These are habitual ways of responding to the world that activate the sort of lower-level systems that we've been talking about. And importantly, although we can recognize alief most easily by looking at these kind of discordant cases, the cases where belief tells you to do one thing and alief tells you to do the other, in fact, alief is active all the time. Every time I've used my right thumb to push the key on this, I've done it out of an alief. Fortunately, it's one that corresponds with what I intend to do. But it is certainly the case that an enormous proportion of our actions are governed by alief. The question is this: given that I just showed you that there are hundreds and hundreds of ways of describing what I've adverted to with the notion of alief, why introduce this new term? The story has something to do with alief itself. So every 20 years or so, the United States government introduces a dollar coin. Here's the one they introduced in 1921. Here's the one they introduced in 1972. Here's the one they introduced later in the 1980s. Here's the one they introduced in 1980 with Susan B. Anthony. Here's the Sacagawea one they introduced in 2003. And in a massive fit of public relations genius, here's the Millard Fillmore gold coin, which will be issued soon. What's going on here? What's going on here is that it's hard to get people to make use of something if it doesn't fit into the currency system which they have already. Dollar coins don't fit naturally into the ways that Americans use money. Likewise, talk of system one, system two, relatively autonomous systems, heuristics, biases, and so on, don't fit naturally into the way that we have of talking about ourselves. We talk about ourselves in terms of beliefs and desires. And in order to make use of the gold coin, that is the recognition of the multipartite soul, we need a notion that fits into our conceptual currency. And that's the role that my hope is alief will play. So alief is going to return to us in later lectures. We'll hear about it again in the context of the harmony of the soul and in other domains. We'll hear about heuristics and biases, and we'll hear about the multi-part soul. I look forward to seeing all of you on Tuesday for harmony and happiness.